negligible globe model.
Do you think it's a ball?
I think that like if there is curvature, it could be like 100 miles of negligible curvature, and that model would more to me. So like I'm not a glober. Like I don't think it could be a globe like the globe model says. I think the sun is hollow. I don't believe in the emptiness and the empty regions of space. I don't believe the Big Bang. I don't believe that orbit is caused by gravity.
So you think it could be a ball, just not to the measurements, and then like the
It
solar
clearly doesn't
interaction?
match. Yeah, in no case have they ever measured, the curvature to match their prediction. It's never happened.
So you're a baller.
Baller, shot caller, only trims.
It's kind of like just a bigger ball in a sense,
Oh well, dude.
right?
Like you want to call me a bluff and try to make a case that
No, I'm
I
trying to
honestly
figure out what.
don't think it's a globe.
No, I'm trying to figure out. I'm not trying to call you anything.
All right. Well, you did this. I'm a
You said,
baller, but okay, that's fine.
well, yeah, but I'm trying to understand your position. So it's like spherical, but just really fucking huge spherical. Do you think like you think the gravity is causing the shape? Like the round formation? Do you think that's what caused? No, because you said you don't believe in the Big Bang.
Not at all.
You believe in a
So
creator
you
then,
said
right?
does gravity cause the shape? That's an interesting question. So you know that's what accretion is. That's what like the surface tension of the water in free fall. Due to gravity. Right?
That's just air pressure.
That's like they say that the
It's
mass
not
of the Earth, like in its liquid state, right? That as it was in free fall around the sun, that the surface of it conformed to here due to surface tension and the fact that it's in freeze fall. It's in a constant velocity.
But you're still off in fantasy land, bro. You can't really hold your world views to a untestable fantasy like that, right? Or is that what you're doing? Honestly,
Yeah, but you have air pressure is what
I'm saying
creates
I'm
the
saying that's what I don't. That's exactly
regardless
what I
of
think of glow.
pressure, electromagnetic stat, like there's so many fucking variables that you can't remove all of them in order for you to get a solid read on anything in reality. But you're gonna
Let me
play
respond.
the thought game that they want you to play, and you're gonna just follow that carrot that they dangled. I don't get that part.
No, I'm explaining why I don't agree with it. That is one of the reasons I don't agree. The whole idea that the Earth is in free fall around the sun, I don't believe that. It have to be the case if we're rotating globe. So immediately, I'm considering that it's not a globe when I say that that's not happening. In order for the globe model to work, you need the Earth to be in free fall. I don't think there's a way around that. That's the most viable way they say that this could be a thing. And I don't agree with it. I don't believe it. I don't think it's true at all. So I don't think it has to be a globe. No, all the time you try to measure force, dude, it's all based on gradients, like density tower gradients and density pressure gradients, based on like the horizontality. Like you create an equatorial plane. It's all based on equilibrium.
My
The
bad. I didn't mean to
extension
come
of
at you like that. I
the
thought you were trying to defend it.
No, you're good. No, that's all good. I wanted to clear that up. Sure. Yeah, all these balance of forces is what's creating horizontal planes for the pressure gradient model. So if something can reach equilibrium, then you're in a two-dimensional plane separating the meets. And they got refraction all wrong. Like what they say is happening see too far, in my opinion, is absolute bullshit. Like I do not agree with the globe's model of refraction and atmospheric refraction and loss observation. That is some ad hoc bullshit. I'm not defending none of that garbage. Fuck that.
As far as the gradients with the pressure and all that, it sounds really feasible, but I think we need to look into weather a little bit more before people make like a concession on that, because I'm pretty sure there's claims out there that there's high pressure zones in low pressure areas and low pressure zones in high pressure areas, which would negate the gradient itself. But those are the reasons why we get all these crazy climatic events out there as well. Like that's why the cloud seeding is to create these differentials and pressure zones in different areas. So I don't think this gradient thing's real that they claim. Even though on a basic scale, yeah, you go up higher, like say the common one, you go up on Everest and the pressure is lower. Yeah, there's that. But I think there's way more too. I think none of this shit is provable.
We can I don't know, we can kind of gauge it in the cylinder, you know?
It's more terbium the model. You could say that. But yeah, dude. Yes, please. You got me over here like trying to make you think I'm
Huh?
so like with what you said. You and are like, you're a
You
globe
keep
there.
cutting out.
You're
Yeah,
in
you're
my
cut.
mind. Every
You're
day I'm
cut.
like, dude, I don't. It's a globe.
You're cutting out. I
sorry.
didn't hear what you said.
Sorry. Yo, is this my mic right now? Can you hear me better?
Yeah, much better.
Fucking slob.
Controller's my microphone. My bad.
No, it was like cutting out, like lagging.
Yeah, I
you
forgot what
say
I
a few
said.
words. You were saying how you and your boyfriend were having a great dinner last night. All right, you're saying something about not being a glober.
Oh yeah, that's right. Thanks. Yeah, I'm saying like you guys got me over here like trying to defend myself. Where I'm like, dude, you guys gotta.
You
I
remember
don't
what you
come into
asked,
these
right?
arguments to
What
just
did,
lie
hold,
and bullshit.
hold on, hold
I'm
on.
not here to deceive people about my
Do you
position. Like when I
do
argue for
you
something,
remember what you
that's my
asked?
position.
You
You
opened
don't
the
remember?
door, yeah.
Yeah, you don't remember what you asked to start this conversation?
You opened the
Yeah.
door, invited
You
us
said,
in
"Who
to
do I
ask you
think is a
questions.
fake flat earther?" Like, so you're basically asking for personal opinions on people. You're not gonna get any smoke. Come on, you know you're gonna get some smoke. If we're gonna be honest. See, I've heard that you were switching back and forth because of personal feelings towards Witsit. Because he said something, I don't know, you basically flipped hard because of what Witsit said or did or something like that. That's what I've heard around the
Yeah,
campfire.
that's the kind of stuff. That's the kind of stuff they're making up at the time when I did start going at Witsit. Really, what I didn't like about Witsit was how he was trying to host his debates in Cosmo Tartaria. He would just come in and make everything about himself. And then I would just hear like how dishonest of a person he actually was. Like when he started engaging with FTFE and McToon, where I was just trying to have like, good conversations with people like Dovid and Jason Wutker and Lalo Thinks and Northern Rebellion and like the kind of people that were hanging out there. Witsit came in and just disrupted it all. And me and Dovid ended up going into private servers. And then like we pop up like how we felt about how the server was changing. And I ended up putting Shane in my crosshairs. I'm like, yo, this dude is like, misrepresenting. Like, I think that he's intentionally lying and he thinks flat earthers are stupid. and he does Duper's Delight, where he like laughs as he's saying something because he knows it sounds ridiculous, but he thinks stupid people are just going to blindly agree with him because they think that he's smarter than him. And honestly, dude, all these flat earthers think Shane is smarter than them. And I'm over here thinking, like, dude, I'm smarter than Shane. That's how I feel. But you can tell people
Shane?
trust Shane's input and not comprehend his model at the same time. That happens a lot in this community. So I started just straight up calling out Shane, right? And then that's when they turned around and started saying, I'm upset because I flipped because Witsit destroyed me, quote unquote. Like, dude,
What
technically,
did
I
Shane do?
destroyed Witsit. Like, if you ask me, dude, Witsit started getting dumpstered on, like, right when I came into the community. Like, that's how I look at it. And now he's not even around, and I'm fucking still here. So we'll see if he tries to ever come back again, even though he got dumpstered on.
Yeah, but
Right?
what
I
does all
ran those
these
guys
like?
off. Shane doesn't want to talk to me. I sit there, I listen to the celestial theodolite. I make my case. He doesn't want to engage. He runs away. All those guys are afraid of me.
Nah,
Well,
What's
bro.
they're
your
trying to
case
flip a
then?
narrative, dude. You're in private servers with these guys. You sit there and you listen to them make up stories about me, right? You think that I'm gonna lie to you, that I have to make up stories. Those
No,
guys are talking about
n-
me,
I
and
promise
and
you,
like
no
that's why they
one's.
have to talk about me because I'm the one that was fucking destroying them.
I promise you, it's not what you think. No one's talking about you, bro.
The only reason I would have any idea of this, like what I think, is based on the stuff that I hear from, like what
You hear from what? Sorry, cut out
Shane
again.
said this and that about you. Yeah, it's just like talking to
It's
like
it's honestly not
talking.
that at
Yeah,
all. The only time that they ever mentioned you is because you asked me, like it was when I brought you up to ask if you can come back into the server. That was it.
yeah.
Yeah, dude, that's it. When I said what I heard around the campfire, this was like a long time ago when you were first. This was like 2 years ago
The
when
reason
I
I
first
flipped
came
is because
around.
I realized that a lot of flat earthers don't comprehend the argument. Like it's actually like feeling like I'm the smartest person in the room. And then in that instance, you should be compelled to go surround yourself with people that you think are smarter than you. And one of the first places I explored was the Glober dens. I went right to medicinal mass media, and I started talking to like Bob the Science Guy and fucking Seafoam. And then, I was like, okay, I understand where the globe is coming from, why flat earthers are absolutely incorrect, why they're falling for Shane's nonsense, and you guys act like he's got some like ace in the hole, and you can't steel man their argument yourself. Like, I don't know why you think it makes sense if you can't reiterate it.
What argument are you talking about specifically?
People think the celestial theodolite makes sense. It makes absolutely no sense. You have this false sense of pride, like we got this like ace in the. To me, it just sounds like you guys don't comprehend trigonometry. That's what it
Nah,
sounds
man.
like. Because stellarium works around the world. All the positions are working, right? Is that not
Yeah,
true?
no
That's what you're
one's.
depending on to find out that
That's
the
not what.
angle to a star. You say, oh, stellarium tells me it's going to be over here. All right, you're depending on stellarium for an angle to a star. You're already done.
Yeah, what the celestial theodolite really is showing is the globes. When they add in refraction, that it basically like the globe only exists through refraction. Essentially, that's what it's showing. It's showing that with these occlusion angles, right? With this occlusion timing, if you just had the occlusion timing and you were going to derive distance and height, then you would get closer to flat every single time unless you fuck with refraction. So it's basically showing the globe only exists in refraction coefficients. If you look at all the data.
I told him this the other day when he Electric. You heard me explain it to you that way the other day, and you just blew it off. You're like, "Oh, okay." It
But
sounds like you
do you
don't
get the
want to hear it.
You get what that means for the globe, though? If that's true?
Yeah.
Like you get what that means for the globe, yeah?
Yeah, he knows. That means refraction's not doing what the claim is.
It means the ball is a different size.
No, honestly,
Best
what Biaski
case.
said didn't make sense. Nope, what Biaski said did not make sense because the angle that the star appears to be getting occluded,
That's
you know,
true.
in reality, yep, you're
Yeah,
gonna shout over
yeah,
me
you're
right
doing
now.
no, you're doing two different. Look, you're not relying on he's not relying on stellarium to do the angle. He's testing and doing his own angle on the sides and comparing it to what stellarium says is happening, and it's not holding up. And the reason why it's not holding up is because, again, they're pushing the narrative that they have to push. They know they have to put it in there like that in order for refraction to be in the conversation. If they don't show those exclusions slightly off like that, then people are going to pick up on it and see what the fuck. This doesn't make sense on the globe model. Why does this make sense? Why is it showing that it's flat? It's that simple. It's not magic. And if I can understand it, you should be able to understand it. I'm like tier 3.
Yeah, I understand it. That's why I disagree with it, because when you say that you're going to take an angle to a star based on when the star is getting included by a mountain, right? And then you have a trigonometric prediction of the height of the mountain that doesn't match reality, right? You're saying the star is getting included at 2 degrees and 31 minutes because that's the trig prediction for the height of the mountain. Is the mountain actually that tall? In reality, no, it's not. It's dropped from the trigonometric prediction. You guys say that there is no atmosphere.
No, they don't
Visual
have a
space
measurement for that. There's just an apparent
is
phenomenon of that.
dropping the height of the mountain.
And this is
You
why
have
we
to
know
say
you're a
that
secret glober is because you're
visual-
claiming drop over distance. You're trying to hold on to the last string that you have, and you hate this celestial theodolite because it punches that hole in there. But there is no measured drop over distance. It's all apparent.
No, I'm not hearing.
That's why there's no contention, but you're not even listening. That's why there's no contention with the height of the mountain, Callie.
Well,
because there is no measured drop over distance. It's agreed upon. Both sides are conceding that the mountain has the elevation that it has. It's that raw. There's no extra shit to it. You just hate it.
I don't think you understand what I'm saying yet, because there is something wrong with the celestial theodolite. A lot of people are aware. You're invoking curved visual space, okay? Your prediction, when you say that there's no refraction, no such thing as refraction, right? It doesn't match that prediction. That's a problem.
I don't know what you're saying.
You say
right now.
there's not refraction.
He doesn't know what he's saying.
Yeah, you turn off refraction. I know
No one's
exactly
saying there isn't refraction. What we're saying is that they're invoking refraction to such a crazy degree that it's ridiculous. That they're basically invoking refraction as like a curve fit formula. And this is what's proving it. That's all it is, dude.
Like
In reality, there's only one in reality, there's only one occlusion timing, right? When you can't see the star, that timing equals an angle. All right? Now that angle, you can interpret it in two ways. If you just compare it to a flat baseline, right? To just plain trig, or you compare it to drop over distance, which is what the globe has, right? 219. All right? And if you derive the distance, right? You're not telling stellarium how far away you are. You're not. That's the point. And you're basically deriving the distance and the height based off of that angle. And what is more accurate, essentially? Which model, is it more accurate towards? And it's always flat. And then the instances where the globe matches more so, or the height and the drop over distance matches more so in terms of like invoking the refraction coefficient towards it, it's a perfect ratio to where the amount of drop over distance is almost identical to the amount of refraction that brings it back up. So it's like specific spots. And this is what Jesse was finding in his simulator. Basically trying to show that the method itself is not correct because of this ratio. But that doesn't destroy the method at all. The method is basically showing that the globe has a curve fit formula for by using refraction. So anytime it doesn't match the drop over distance that's required for the geometry of the globe, then they invoke just the right amount of refraction to bring it back to a flat baseline again to match that occlusion angle.
Is there such thing as refraction in the atmosphere?
Yes, but not to the degree that they're invoking it. That's the
Which
point.
way is it? Which way is it bending the path of light? Are things appearing lower than their geometric position, or
In all
higher
directions.
due to the density in the atmosphere?
In all directions.
Yeah, it just depends
That
on
doesn't
like
make sense.
the
Beam
Okay, so-
scattering. Look at
so-
beam scattering. It'll explain it.
No, dude, you're talking about vertical displacement. Okay, you're saying that the star is displaced vertically from its actual position, right?
See, that's the thing. That's the thing, right? Celestial refraction doesn't have temperature or pressure as a variable in its formula. That's
Which
insane.
makes no fucking sense.
Exactly, that makes
Because
no fucking
refraction
sense.
is
I know
based
that already. In
primarily
your
on
model
temperature.
right now, the reason why the star appears at 19 rather than 2 degrees and 31 is because of curved visual space with no refraction, causing the
No
apparent
one's saying no
vertical
refraction.
displacement. What is okay? So there is refraction. What is the refraction doing to the position of the star? Is it dropping it? Is it raising
Are you talking
it?
about the mountain or are you talking about the star? Like, what are we talking about? Because there's terrestrial
I'm
refraction
talking
and
about the
celestial
star where
refraction.
the flat Earth trig prediction for the star was 2 degrees and 31 minutes. In reality,
It's like
when you measure the
234.
angle to the,
Yeah.
you measure the height of the mountain, it's 2 degrees 19 minutes. What is causing the
Well,
displacement
when
of
you
the
say
angle?
measure the height of the mountain, you're talking about shooting at the Theodolite to the peak of the mountain in daytime, right?
Okay.
All right, so you're shooting an angle to that mountain. You're using a modern day Theodolite that's accurate within 1 arc minute or so. Then you're using a level transit, a David Weiss 8300, and that's accurate within 5 arc minutes or so, and that has 231. So which one is correct? Why is there such a discrepancy using Theodolites or transit, right? What is this discrepancy in the visual space, right? In optics, okay? How can you have a mutually exclusive way to figure out which one is more accurate? This is where the celestial Theodolite, got its fucking birth. He was like, okay, so if we use
That level
the time,
transit,
uh-huh,
yeah.
the level
That level
transit,
transit, you're saying measured the angle to be 2 degrees and 31 minutes is
Yeah.
irrelevant. Someone came through with a better theodolite and
how's that irrelevant?
measured the angle again, 2 degrees and 19 minutes.
It's not irrelevant. Because if it's
Yeah, it
within
is. They
5,
got a better
if it's within
measuring
plus, if it's within plus 5 arc minutes, okay, or plus or minus 5 arc minutes, then that would still be 226 or 236, which is still not 219. And there's a big discrepancy, right? So again, if what we're saying is there is curved visual space, right? We see in non-Euclidean. If that's true, okay, then how can you differentiate between things dropping over a distance due to your visual optics or due to Earth curve? Okay, and so how do you figure out which one's more accurate? That's the point of the celestial Theodolite. That's why you
Dude, the
use a
most
star
important
as an
question
external
is
as an external reference. I don't understand what you don't understand about that.
the most important question in all of this is in your model, does the density of the atmosphere, like the denser it is,
In your
does
model.
it make the star appear higher than its geometric position?
So you keep saying in your model, right? As if there is a flat Earth model.
And as if you're not a
Refraction do
flat
what it's
earther.
claimed to do on the. Does refraction do what it's claimed to do on the globe?
You
Like, do you
sneaky
agree that
fuck.
light bends towards the denser medium? Calm down, French. It's just me honestly critiquing
I'm
the
just trolling, bro. I don't care. I'm not that of a.
I don't get your. I still don't understand you're asking like non-ending questions. Like, what don't you understand about the celestial theodolite?
Is the density of the atmosphere vertically displaced the geometric position of the mountain higher, the geometric position of when the star gets occluded, higher than the prediction? Is that what's happening? Does refraction displace things how it's said in the globe model?
Okay,
You know,
how can
light
something
bends towards the
refract if you
denser
can't see
medium.
it anymore? Then what? How can you tell if
It's
something's
the path
refracted
of
if you
light
can't
is still
see it
being
anymore?
refracted because the atmosphere, because the atmosphere is refracting the path of light before the mountain.
Okay, we don't care about when it's before we can't see the star. We care about when you can't see it. Then you mark down the time. Oh, I can't see it anymore. What angle is that?
Is there density in the atmosphere causing the path of light to bend down? Agree.
Why are you asking these questions? Of
Yeah, but you
course
know
there's
that
density in the
Because
atmosphere.
this is going to tell me not the star is displaced into a higher position in your modeling.
yeah, but now
Like, do
you're
you agree
saying
that the
drop
density
over
of the
distance is downward refraction. That's all you're saying.
Dude,
You're
this
saying
is
like the
why this
only
is part of
time
the reasons why I flip. Because flat earthers do not comprehend the model. You guys do not understand what is happening with refraction. Light
you
bends
don't
down
they
towards the
don't
denser
have a
medium,
refractive model. There is no
making the
refractive
target
model. Get
appear
that
higher.
fucking bullshit out of your head. There's no refractive model that works in all cases. This is
Yeah.
proven. It's demonstrated multiple
That
times
doesn't
by
make
multiple
sense. Okay, what you're
governments.
saying actually doesn't make sense, so you know.
It's a reality. It doesn't matter if it makes sense.
In reality,
It
the
is
denser the medium the light
bro,
is passing through,
bro,
the
let me explain
higher
something,
the
right?
target's going to
So
appear.
so are you familiar with NATO Sapphire, right?
Do you not understand what I just said, dude? Do you agree? Light bends down towards the
Want to
denser medium.
argue.
Yes or
You don't
no?
really give a shit. You just kind of want to argue about it.
I want to know if you comprehend the
Yeah,
opposing
you just
argument
want to argue.
that you think you're
I'm trying to
addressing.
explain
Do
refraction.
you
Yeah,
understand the model of
I'm
refraction?
trying to explain refraction to you, right? Because you keep making these claims as if refraction is an absolute thing and figured out. And like you don't know what refraction is doing. No, nobody knows what refraction is doing. Full stop. That's
So you
refraction.
don't know that light bends down towards the denser medium. That's
And
what
it
you're
bends
saying.
up, right? It bends up, it bends down, it goes all kinds of way. There is no formula that works in all cases to match the observation. And the reason I know that is because a bunch of governments have ran tests and experiments. They release the findings to the public, and you end up like NATO Sapphire. You end up with 10% of your observations being 2 to 4 times outside of your window of tolerance. So you had the model right with refraction 90% of the time. But 10% of the time, you have no fucking clue what's going on because all your math just says, well, this isn't accurate. Right? It's off by 2 to 4 times within that 10% window. You have 2 to 4 times out of tolerance. That is so far out, like so far off the formula that it's like, well, this just doesn't fucking work for this observation. What is going on? Like we are so far out. We thought we could predict it. We thought we could assume what the light would be doing, what the light should be doing, because this is what it did 90% of the time. So why is it acting different now? There's no answer for that.
Yeah, there is an answer, and I'm going to tell it to you right now. All you
Oh
have
my
to
God.
do is go into stop complaining when you're actually getting debunked. All you have to do is go into a
You're a debunk
laboratory
guy. You're not
and change
debunking.
the. You're saying that you can't know the path of light as it passes through different mediums.
No,
That's
no,
a
I'm
lie.
telling you
Okay,
that
you
is
can
what NATO
literally go in a
Sapphire
laboratory
experiment
and
proved.
change the density of the
It's in a
medium the light
lab,
is,
dude.
Bro,
and
The air
see
is
how much
dynamic.
it changes the path of light. Stop interrupting. You hear my argument is sounding. You're trying to talk
No,
through
the
it.
air
You
is
need to sit here and
dynamic.
accept what I'm saying. Nope, stop. No. Air has
No,
a
it's not.
density, dude.
He wants to talk
Yes,
about
you can measure the
spectroscopy in a
pressure. You can
fucking
measure the
lab
pressure and
environment.
density of the air. You can know the barometric pressure in the
Okay.
air.
If I
Measure it.
didn't,
Then
all
you
right. Let me stop you real
take
quick.
that density.
If I
Take that.
didn't,
Stop interrupting. Stop interrupting me.
no, wait. This is
You
important
listen
because we're
close,
talking about
dude.
the
This guy
celestial
doesn't know.
theodolite.
Stop.
Hold on,
Stop
wait. This is
muddying
why
the conversation
I'm not.
with garbage,
I'm
dude.
bring.
Let me finish my point. Then let me
No, you
finish. Stop
made your
interrupting
point.
me.
You
Okay,
made your
listen.
point.
made your
Listen
You
point.
don't
close.
understand the point others are making to you.
I'm
You
tired
just
of you
keep making
dishonestly
claims.
interrupting me.
No, you're the one
Stop
being
complaining
dishonest.
and let me finish the point.
You're
All right,
trying to
dude.
compare.
You're seriously complaining,
Hold on,
ignoring the
Pure.
point
Hold
that
on,
I'm making.
Jesse. Let me just pose this to you.
I'm
You
not going to
just
stop
said.
until I make my point, dude. I am not done.
You have
Just
no
stop
fucking
talking and
point.
let me finish.
Well, I want
I
to
do have
stop
a
you
fucking
because you
point. You're
did.
just acting
You
ignorant
said
for
a
no.
point. You
Stop
said a
acting.
point.
Stop
And
interrupting me.
I want to challenge you on your point. You said you had to
You didn't let me finish
measure
my point. Let
the
me restate my
temperature
point.
and the pressure, right? You have to measure it to know the refraction, right? So where is that in the celestial theodolite observation at all? How can they invoke refraction if they don't measure it?
You can know how much light is being displaced. You can control the
Without measuring
variable.
it?
You are measuring the angle of incidence. The angle of incidence from one medium to another, the variation in the density, right? The path of light change, the amount it's displaced from its apparent position. You
Yeah,
can
where
measure
is
this in a
that
laboratory,
in
change the
observing
density.
stars?
You can know the angle of incidence depending on the density of the mediums.
Okay,
Are
how
you
can you know
fucking
the
fucking
density of the
serious, dude?
medium? How do you know the density of the medium if you don't measure it? You're just looking at stars.
How are you saying you can't measure the density of a medium? What are you
I'm saying
You're
they're
s-
using refraction coefficients willy-nilly without actually measuring the density of the medium, as you said that you need in order to invoke refraction. They're invoking refraction without knowing the density of the medium. That's the point. That's the point of the celestial
So you
refraction.
don't think you can know the density of the air out?
Yeah, you can if you measure it. That's what he's
If you
saying.
measure it. But they're
No
invoking
shit, they've done it.
refractions. They're invoking celestial refraction as a curve fit formula without actually measuring the density of the medium that the light is going through. They use a homogeneous model essentially where the celestial refraction starts from the center of the earth and then expands towards the surface, and it's all homogenized. And it's just a curve fit formula depending on the angle of that you are to the horizon. So when you have horizon angles, right? Like when you have angles that are closer to the horizon, you're going to have a huge refraction coefficient. Why? Because it has to in order to fit the curve. But there's no measure of density. There's no measure of density. They're not measuring the air at all in order to invoke it.
There's no density to air. Okay, that's great.
No, they're
That's not
not
what he-
measuring it. That is the point.
They're
We're
not able to
exposing
know the pressure
We're
gradient.
exposing
Okay,
their
dude.
use of celestial refraction as a curve fit, when in reality, you can't just invoke refraction, like you said, without measuring the density of the medium. That is the point. And that's what it's exposing.
Gravity over time has stabilized the pressure gradient. You could literally measure 14.7 psi all around the Earth.
Now
For you to
who's
say that you
invoking
don't know
shit?
the density or the air pressure is a sick joke. It's
Bro,
not this
bro,
ambiguous, eluding
bro.
thing
What about wind?
reality.
Wind doesn't affect pressure. Temperature doesn't affect pressure.
Wind doesn't
It doesn't
completely
affect density.
destabilize the pressure gradient.
No, it
That's
changes
not
it.
what happens when there's wind.
It changes it. It modifies
No,
it.
what really changes it is the lapse rate due to the temperature variation. Temperature is
So
what
what does wind do?
changes density.
So wind doesn't carry temperature?
Temperature changes
Doesn't
too.
change the temperature? Wind changes
Sunlight
the
carries
temperature? Yeah,
temperature.
so does the wind. It all influences it. I mean, this is going off of official fucking papers of what they're saying, right? They do it in a lab, right? They do the spectroscopy shit, shoot it through like all these mediums, everything, right? Ricochet it, get it to do what they want, right? They do all that in a controlled environment, right? Then they do long distance experiments, and it doesn't match up. They have serious issues with it. They can't
No, the
predict
serious
the
issue
outcomes.
is that there is a majority of the that's looking at the celestial theodolite like, what is wrong with these people? They're pretending refraction doesn't exist, and they're
No
invoking
one's
curved
saying
visual
that.
space as if,
My goodness, dude.
yeah, that
You're
is
just being
exactly what's
you're
happening.
just
You
being
guys are
impossible.
turning off refraction.
No, you're
Yes,
not
you turn
listening.
off the refraction corrector. You pretend that there is no atmosphere, and you appeal to that globe prediction
So he's
because you think
granting
that the
it seems
path of
like he's
light from
granting,
you think that the
like,
light coming from
guaranteed
no, dude. I
refraction.
know you don't understand this, Rigger.
That's what
Honestly,
yeah,
either
that's
you're
what you're
completely
doing.
retarded or you're
You're
LARPing right.
granting the globus,
So I'm
right,
not interested in your.
guaranteed refraction.
I'm
That's
not. I'm
exactly
not
what
talking to
you're doing.
you. You're
You're saying,
pretending you're
"Alright, so
extremely ignorant. I'd rather talk to
so for the globus,
BS.
right, it works because every time the light is gonna refract like this. Even though we're not measuring it, this is what it's gonna do, and you just grant yourself that without and you say, "We don't need to measure it because we did it one time in a lab."
No, you're the one who said it's never been measured. It has been measured. You
No, I'm
understand what's going
saying
on
No,
in
no,
that
no, no, no,
reality? You
no. It's
claiming
not
that
that
you
it's
can't
ever
know
been
the density
measured,
of the
bro.
I
universe.
never
I'm
yeah.
saying if you're gonna invoke a certain amount of celestial refraction on stars, right? On the apparent star position, okay? You can invoke it for sure. But how do you know how much to invoke? Where are they getting the numbers from? Oh, I know. They're literally just doing it off of empirical observations. No measure of temperature or pressure. There's no measure of anything like that in their refraction formula. Don't you understand? Like, that's crazy. They're just invoking it because it's supposed to fit the curve. That's it. It's just a curve fit.
Invoking it because there's density in the atmosphere.
How much?
It's definitely creating a displacement from the actual position of your target.
But you
This
can't
is
measure that
measuring the
beyond a local point. You're the observer. You can make a local
What are
range.
you saying?
But
So
if you're,
therefore, it
I'm
doesn't
saying that
exist
all of
when
these are long
literally
distance
it's
observations, and
displaced from
over
the
these long
position of
distances, weather and
flat Earth
temperature
prediction.
changes on a wide scale. You can go to a lake on one end of a large lake, and you can have conditions on one side and another side. They're different. It's not that hard when you're dealing with 100 miles around there of observation. You can't guarantee that the weather's the same from where you are all the way to where you're observing. That's absurd. And
All
they know
right.
that.
So
That's why they just made it standard.
how are you
It's
determining that that's the reason why things are displaced from the flat Earth trig
They're
prediction?
not. They can't. That's why they just made it a standard, and because it fits.
Things are not displaced from the flat Earth trig prediction. Are you sure?
Dude, no one's saying that. And if you looked at the data, you would see that no one agrees with that because there is deviation even from plain trig. The question is,
You guys are
what is
yet
more
to even
accurate to
hear what my
reality?
argument is. Do you
I don't
realize
know.
that the whole point that I'm trying to make this entire time has not been
Could you
made
make
yet?
it already?
I want you to understand that.
Then just make it already.
I want you to understand that. Okay. Yeah. Okay. I
This
will.
is what
So this is it. This is the
light
point.
does,
Stop.
and
Hold on, wait.
it's
Let him
gonna
make
Now
his
do
you're
this.
point.
now you're intentionally wasting time. That's pure rigor being decided.
Yeah,
No,
that's
just make your
you this
point.
whole
You have
time.
curved visual space in your model. It doesn't your prediction, right? Okay, your cause for the displacement is curved visual space. Okay, that is if there is no refraction, right? The angle to the star, the theodolite, is 2 degrees and 19 minutes,
When you
right?
say
So
displacement, what do you
therefore,
mean by displacement?
I'm saying that the flat Earth trig prediction, no refraction, 2 degrees and 31 minutes. The angle measured with the theodolite, 2 degrees and 19 minutes. You have to invoke that something is happening causing the vertical displacement. The angle is lower than your prediction. Rather than it being 2 degrees and 30, it's 2 degrees and 19 minutes. You have to invoke
Uh-huh.
some effect that is making your target appear lower than the geometric flatter prediction. Okay, that is curved visual space. In your model
Okay.
right now, that is the only way you explain it, because if it were refraction, right, atmosphere, it's not dependent on density, it's not bending down towards the denser medium. You're literally
Oh,
inverting what the effects of refraction are. If you're saying
hold
that
on a
it's
second.
sinking refraction, yeah.
Hold on
Okay,
one
now you
second.
understand my argument?
Hold on. Yeah.
Yeah, dude.
So here's the thing. You have an angle of 219 to the mountain peak. All right. And you have two interpretive models. Let's just say models for now. One, you have that angle displacement because of drop over distance because of a curved Earth. Two, curved visual space because between you and the object, there is air. There is a dense medium between you and the object, right? So which one is correct, Jesse?
Yeah, the density of the air is going to bend the light down.
Right. But I asked you
The
a question
path
though.
of the light between the path of the light from the target to the observer,
Okay, which one's
bending
correct?
down towards
Which
the more
interpretation is
dense
correct?
region, right? The densest part of the atmosphere is near the Earth. Do you agree that
Yes, yeah.
the
I'm
density power
asking you
gradient
which interpretive
decreases in
model is
density and
correct to
pressure
you.
as you gain altitude?
Can you answer my question, please?
I'm telling you what's
I know,
measurable
but
in
I asked you a
reality.
question in good faith. Can you please answer it? I answered yours. Which interpretive model is correct? Is it drop over distance because of a curved Earth, or is it because of some type of curved visual space between you and the object? Which one is correct? Just be honest.
It cannot be due to you are pretending there. Listen, you're pretending there's no reaction. When you say that the only effect that's displacing where it should appear on a flat
Why
Earth
don't you answer the question?
prediction, because I'm answering it how I want to answer it, and you're going to understand my position better. Say what I want rather than dictate the answer
It's
to the
just a yes,
question.
no, or I don't know.
It's not that simple. It's not
It
that. It's
is.
more
And then you can
nuanced,
elaborate
and
why
it's a loaded
afterwards.
question.
I
I'm telling
know.
you why it's a loaded question.
I know it's a loaded question. It's on purpose. Because the honest answer is I don't know. I don't know which interpretive model is more correct. That's why the celestial theodolite observation was created. You take occlusion angles from when you can't see the star anymore. That's it. And there's 3 different
If you
angles
have,
that you want to
if
invoke.
you, okay, dude.
Sorry, go ahead. It was a
If you
lag.
have, yeah, I'm gonna say what I wanted to say. If you have density in the atmosphere, that's going to mean that there is a decrease in density. Density power gradient, it decreases in density with altitude, right? The path light
Yeah,
coming
looking
from
at
the target is
mountain
going to
peaks.
bend
Yeah.
down, making it appear higher. This would be the effect refraction, right? Typically, this is the effect you can expect, is the actual raising of the apparent position of. You agree?
Kind of cut out there. You're a little choppy.
If refraction is real, the density is going to raise the apparent position of the target. The path of light from the object to the observer is going to bend down, making the target appear higher. That's what the atmosphere is going to do if the density tower gradient is truly measured to be decreasing in pressure with altitude. Do you agree? Because if you
Decreasing
have
with
curved visual
pressure
space
and
making things drop,
Mhm.
it appears lower than the flat Earth trig prediction. And it would be already being refracted to appear higher. Right?
It would
So
be
for you to say
refracted
that
to
a
appear
closer
higher. Hold on, let me chew on what you're saying. It would be refracted and appear higher. What are we talking about, the star or the mountain?
angle to the mountain. When the star
Okay.
got occluded, that angle was 2 degrees. I'm sure we agree that's what was observed in reality. Reality did not match the flat Earth or globe prediction.
Well, I didn't. You said in
Okay,
reality the
so
angle what? You keep cutting out, dude. It's really bothersome. Your
All right,
words are
sorry.
cutting out. You said in reality, the star occluded at what angle?
In reality, the star got occluded by the mountain at a specific time. Okay, if you at any point in time, you can measure the elevation angle that shouldn't be subject to too much change.
Bro,
If you're
you're
saying
still
that the
cutting
density
out,
of the
dude.
atmosphere is really,
You're cutting out like every third word. You have another microphone you can use, or
Stop trolling, Callie.
yeah, why don't you actually form a valid response?
Make your goddamn
Like,
point.
instead
It's
of
been
just-
an hour and a fucking half.
Yeah, let me see if I can knock off some of this lag you're saying I have. Yeah, Fresh, I question if you understand refraction globe model. Like, you just shouting random shit that.
Yeah, there you go. Way to sidetrack away from the conversation and you making your goddamn point after an hour and a half and crying like a little baby about it.
Yeah, I've been making my point over and over again. Light bends down towards the denser medium, which makes it appear higher than the geometric prediction if you were on a flat Earth, right? The geometric prediction for a flat Earth, the angle to the mountain should have been 2 degrees and 31 minutes. It appeared lower than that. It was
the
lower than
mountain
that
or the
angle.
star? Because we
The
don't give a fuck
mountain.
about the mountain. You do realize
You
that,
should.
right?
You should. You're invoking curved visual space and no.
This is going in circles, bro. We're talking about stars getting occluded by mountain peaks. All right, that's what we're talking about. No one gives a fuck about the mountain. We're not Jesse Gordon shooting fucking 75 miles away to different mountain peaks and be like, well, look, there's missing height. Oh, it must be a fucking curve. No one gives a fuck about that because you can't prove whether it's curved visual space between you and the mountain because you don't know the density of the medium between you and the mountain versus Earth curve. No.
You're saying you don't know density between you and the mountain. That's a
Here
lie.
it is. He's granted himself guaranteed refraction right there.
Yeah, that's crazy.
Hey, so
Auto Glover.
are you worried about refraction between the observer and the mountain electric? Is that what you're worried about?
That's what you should be thinking about. That
Okay,
you
yeah,
have
cool.
a
So
flat Earth.
is-
You have a flat Earth prediction. It's 2 degrees and 31. Your prediction has no refraction in it. If you account for refraction in your prediction, which is reality, there is refraction. Your angle should be higher. The flat Earth prediction is actually something like 2 degrees and 40 something minutes. If you consider that there is density in the atmosphere, which is reality.
Okay.
So you're not appealing to reality in the base, in the
Stop invoking reality as if you have a better interpretation of reality, first of all. This is probably why you're never going to get anywhere. It's because you keep making claims of reality. Next was that you're not really too concerned with refraction between the observer and the mountain peak at all. Because what you're doing, you're looking at an observation, like an image at a distance, and you're looking at those two images colliding together. There is no refraction to be concerned about between the observer and the mountain itself.
That's a lie.
No, it's not.
No, see, like this is the trick you kind of got to get your head around a little bit. I drew it out on a graph, and as soon as I started drawing it out, I was like, oh, I see what's going on here. Because it's the image at a distance. I mean, you're not even really taking the angle measurement of from the observer to the mountain. You're making a calculation.
Exactly.
That's how you get that angle. So you're not even worried about this angle at all. It's not even relevant to the discussion. it's looking at the two images collide together, the peak of the mountain and that star colliding together at the distance. You don't need to worry about the refraction between you and those two images joining together. You don't need to worry about refraction between you and there at all.
So you don't think refraction is affecting the height of the mountain between you and the mountain?
It would be, yeah, I'd say it would be. But the trick is,
so why are you saying you don't have to worry about it?
Because there's two images that you're looking at the distance, and those two images are colliding together. That doesn't it doesn't matter whether they're both because they'd both be bending up or they're both bending down. It doesn't matter.
Exactly.
That's why you can remove refraction.
Is the peak of the
together.
mountain? Is it being refracted? Yes or no? Is the mountain being refracted to a higher position? Yes or no?
Sure. Yep. Yes.
Yes. Your answer is yes.
But so's the star, right?
Okay. So then the geometric prediction in reality, if you are evoke refraction, because there is density in the atmosphere, that means that it's actually really far from prediction. Oh, I see that my mic's cut. Let me get my better mic. 1 sec.
Told you it's cutting out.
Am I explaining this all right, Biasicles?
Yes. It's fine. It's the same optical corridor. Yeah. It's the same optical corridor, whether it's bending down, up, and to the side. Doesn't matter.
It's just those two images at a distance colliding together. I don't even understand why you'd be worried about refraction between these. It's not even. I don't get what he doesn't get at this point. Because you don't even worry about the angle to the mountain. I think it actually causes confusion.
Yeah, how's my mic
It's not
now?
measured. It's calculated. So, and that's pretty much all you need to worry. It's calculated. It's not measured. So why are we even worrying about this angle to the mountain? As far as the discussion is concerned, you should be concerned with the height of the mountain and the distance to the mountain. That's all you're caring about.
Yeah, which doesn't match your flat Earth prediction. The height of the mountain observed in reality does not match what you predict on a flat Earth. Do you understand that?
Yeah, here's the problem with that statement, though. Here's the problem with that statement. You have a certain distance that the observer was actually away from the mountain, okay? And you have an actual height of the mountain, right? A known elevation, right? And what you're doing is you're taking the occlusion angle and seeing what it would match to more closely to. Like, what is it going to match more closely to? Is it going to match a geometric Earth curve, or is it going to match plane trig? And guess what? The occlusion angle, right? When you derive the height and the distance, it's closer to flat Earth.
That doesn't matter because there's refraction, right?
It does matter. You're making triangles. It does matter.
No, actually, you guys keep appealing to the celestial theodolite, which actually doesn't matter at all, because you're presuming and don't interrupt, because it's literally a bunch of people just squawking stuff that doesn't apply to what I'm saying at all. I'm pointing out something, an observation made from his house to the mountain. They brought a real theodolite. They used the theodolite to measure the angle to the mountain, 2 degrees and 18.5 minutes. It does not match the flat Earth trig. Therefore, you have to invoke drop over distance. Okay, what is causing the drop over distance?
There you go. That question. That was my same question to you. And you said, no, I don't have to answer it. It's a loaded question.
Exactly. What is causing the drop? Because if it is being refracted up, it's actually dropped away further than what you're saying is like closely matching a flat Earth. It's only 11 minutes from the flat Earth, but it's like 20 something minutes from the globe prediction. It's actually refracted up still, according to you guys. You're saying that the density of the atmosphere is in fact raising the position, so there is refraction. So the angle, the true angle, is not 2 degrees and 19 minutes.
Okay. Is it raising the image of the star, or is it raising the image of the peak in your interpretation?
He's just trying to keep bringing it back to the peak and not talking about the star. I don't know why you keep doing that.
Because the star is not relevant at all. We actually
Really, it's not
know the
relevant at all
angle to
to
the
a
peak.
celestial theodolite observation. Yeah, well, then you don't understand the method.
I'm not
the
talking. I'm
concept.
not talking about a celestial theodolite. I'm talking about an observation made with the theodolite. I'm not talking
You're
about your
basically
celestial
taking
theodolite right
Jesse's
now.
arguments to mountain peaks, basically. Jesse Gordon, remember when he did theodolite shots to mountain peaks from 75 miles away and basically showed the graph where it's like, well, it matches drop over distance of what it would be for an Earth curve. That's all you're doing. We heard this argument like 5 years ago.
Why
No
are you
one cares
Jesse's
about that. No one cares about that because
Because it completely falsifies your claim. That's why you're pretending like it doesn't matter.
because number one, you don't know why there's missing height of those mountain peaks, right? Because you don't know the optical corridor between you and 75 miles between you and the mountain peak, all right?
It's 50 kilometers.
50 kilometers. No. I'm talking about Jesse's observations, all right? Because that's what you're arguing. You're arguing mountain peak elevations, okay? We're arguing mountain peak elevations and distance using star occlusion times. That's the celestial theodolite. It's completely different. We're using external reference to basically figure out what is mutually exclusive, curved visual space or drop over distance because of Earth
Curved visual space. What causes curved visual space? Why is it dropping over distance?
It's just the way optics work, man. That's just how it works.
This
This is a perspective argument.
It is what it is.
This is a perspective argument. We can argue optics all day, and that was also what Dr. Mike brought up because he was listening into the arguments and he was like, wow, hearing all these optical arguments, right? People invoke refraction willy-nilly. It becomes an unfalsifiable argument. Like you can just keep going back and forth, like never ending.
That's projection. You are doing that with curved visual space. You just invoke it however you want and not actually have any math or evidence or observations to back it up. You observe drop over distance. You're just invoking that is due to curved visual space.
There is math for. Okay, you guys have been going in circles for a while. I guess I'll say something.
Say something, Riggs.
There is math for curved visual space. Okay, and they can test it because you can do it in a really small area. The problem is when you expand it over a very large area, you're inviting more variables. And so when they invoke curved visual space, it's essentially like the complex version of perspective. I guess it adds like a third
the target's already been refracted up due to the Atmos, so it's actually dropped further than what you observed. So it's dropped further, literally in reality. That has to be the case.
Well, all I'm saying is that I somewhat agree that like there could be a net effect taking place. I think there could be more than just curved visual space. So,
but how do we differentiate it?
Well, this is like, I think this is where like the celestial theodolite maybe bites off a little more than they can actually claim. Because yes, curved visual space is a thing, but like, has it been isolated? And like to what
degree?
We
don't care about between the observer and the mountain peak. We don't give a fuck. That's the point.
You absolutely should.
Oh no, that's not
this
what I'm
actually matters.
I'm caring
about.
He's saying we should.
Have to invoke some kind of thing. Something is happening, right? You should know the math, exactly what's causing your drop over distance.
No, you're making it into an argument that it's not. We're not arguing curved visual space.
This is why people aren't fucking with y'all's argument, dude, because you're not addressing this. You said it doesn't matter. We don't care, dude. Everybody else cares.
Dude, I've been addressing it for the last hour, dude, and it's just you don't want to talk about the star occlusion angles for some reason. Is it just a coincidence? Oh, it's just a coincidence that the occlusion angle happens to match more closely towards a flat Earth than it does a spherical one. Is that just a coincidence?
The occlusion angle is not 2 degrees and 31 minutes. It's 2 degrees and 19 minutes.
No, it's not. It's 2 degrees and 34 or 33. actually. If you look
That's
at the
not the height of
data,
the mountain.
have you looked at the data?
Where it appears in reality is not matching your prediction, dude.
See, that's my argument, and that's why I say when you derive the distance and the height of the mountain peak, right? The distance to the mountain peak and the height of it, and you derive it based off of the occlusion angle, guess what it closely matches to more so?
It does. You keep bringing up the occlusion angle. The occlusion angle, dude. The occlusion angle is
The most important part of it.
It's the
Yes.
vertical angle of the peak. It's literally the same thing as the height of the peak with your trigonometric prediction. It's the same thing. It's 2 degrees in 19 minutes.
Listen,
It doesn't match your flat Earth prediction, dude.
listen. There's only
That's
one.
fucked up.
Hold on.
Yeah, and it's like, dude, why isn't that
Listen.
an issue to you guys?
There's only one known distance, or there's only one distance, and there's only one height that the mountain truly, the height of the mountain is truly at a certain height, and the distance to the mountain is where the observer actually was. Those are set in stone. You can't change that, right? It's all about where you are actually observing the mountain from and how high the mountain peak actually is. And what you're doing is you're basically using a star as an external reference, okay? And when you can't see that star anymore, and you basically take that occlusion angle and that basically is a time. That time equals an angle. And when you get that angle, right, you take the geometric angle of the star, right, based off the true zenith position of when it was actually measured, based off of the 15 degrees per hour from the first cusp of Aries or whatever. And it's basically just a timing, and that equals an angle. And in almost every single instance, except for the instances where you have the ratio of refraction versus drop over distance to where it's almost equal, does it actually match more closely towards the globe? That's it. Those are the only two examples: Blinn Mountain and like Cheyenne Mountain. But if you look at all of the data, okay, there's 43 observations. 43 out of 46 match more closely towards a plane Earth. Is that just a coincidence? Is that what you're claiming? Oh, it's just a coincidence?
No, in my opinion, it does not match a planar Earth because your
more
planar
closely.
Earth has refraction, right? So your prediction should be higher than the prediction where you invoke no refraction. So what is your true flat Earth prediction with refraction? It's like 2 degrees and 40 something minutes, and that's not the case. So you need to get what your prediction is down correct. You guys keep saying you're in a vacuum. The flat Earth prediction, we think it's going to be 2 degrees and 31 minutes. Oh, so no refraction, so it's not being displaced vertically at all. No more density in the atmosphere.
No one's saying that. No one's saying that. And
Your
it is being
confidence,
displaced.
your confidence in your ability to comprehend this is what's got you trapped in this purgatory of not being able to know where you are and what you are.
That's just an ad hom. You don't know how to address the argument.
I don't know. I'm done. I've explained it multiple times, and you keep invoking the observer to the peak as if it matters.
It's the only actual measurement you've done.
Incorrect.
No, you're not.
Hey.
You're not measuring the angle in reality from the peak to the star. You're not measuring
That's
in
what
reality.
I wanted to know.
Yeah.
Did anybody I mean, that sounds like a task, bro. Like has anybody done that at all?
What matches reality? You guys don't even. You guys aren't appealing to the reality.
What matches reality is.
I asked
reality.
Beast, hold on. I'm sorry,
What did
bro.
you ask?
Say it again. Yeah, but I asked you.
No, but could you repeat your question?
I'm sorry. I've been up. Has anybody done it?
Has anybody done
from the
that?
mountain?
Done what?
Just to make sure that angle is what is, and not just what Stellarium says. The non-refracted or whatever, or I guess even the refracted, I guess. Or like
the angle is what Stellarium says.
Yeah.
I'm not really sure what you're asking.
You guys don't.
Well, I just want to make sure that
like,
from the top of the mountain, the angle to the star is even what Stellarium says it is. That's all.
Yeah, from the top of the mountain to.
Yeah.
No,
they're
no
in the
one's
eclipse.
actually physically confirmed that by going to the top of a peak.
I'm
Sure, you-
curious though. Isn't that like curious? Like what if
Well, I mean, how would you get the occlusion angle timing? Like that you'd have to have two
you'd
people
have to
that
do it at exactly. You'd have to have two people and you'd have to be
That'd be
like
cool.
call
That'd
on
be
the
cool to
on a
do.
phone call, and you'd just be gooning until the occlusion happens. I mean, I don't know what else.
Gross.
I don't. Yeah, I don't know. I don't. But that
Yeah,
would
that'd
be cool, right?
to do.
Yeah.
In the meantime, let's talk about the occlusion angle. All right. And what that actually means. What it means is that people are invoking celestial refraction to such a degree that it's ridiculous, and that the globe actually only exists within those refraction coefficients. It's a curve fit formula. That's what you can see from the data. And there's multiple peaks and multiple observations that people have done in different locations. And it's pretty significant, because then it puts the ball back in the court of the globe, because now they have to justify these refraction coefficients that they just invoke willy-nilly.
Right.
That's the point.
I think there's room for clarification on both sides, though. Like it definitely puts the globe up against the wall, but now this is like a new field of study for flat. You know what I mean?
It's like it's not really about what it is, more so what it isn't. And what it isn't is the radius ball of 3959, because these refraction coefficients are insane, dude. Some of them are just insane, and there's no actual rhyme or reason why certain refraction coefficients are added on versus others, when it's like almost the exact same angle, almost the exact same distance and height. It's literally just a curve fit formula. There's no temperature or pressure in the variable to calculate the certain amount of refraction. And then you have globers like Ruhif invoking terrestrial and celestial refraction. It's crazy. Absolutely nuts.
I fuck with that, man. I totally agree. I think I think that's correct.
I mean, I feel like
they are definitely lying, and they're covering up, and they're strawmanning the claim.
Yeah, it seems
I feel like, Jesse, you have all the tools in front of you that you need in order to do the work to prove the point that you want to prove, but you're just like screaming about a point and not doing the work to show it. If you know the difference in the angle for what it should be with using refraction, you have all the data on the spreadsheet. Go back in there, apply that, and then do the math for the differential of when the occlusion should have happened. And find and prove your point. It's that simple. I mean, I don't know what's the big, come in here and make a big scene about it. It just doesn't make any sense.
Oh, he just likes to debate.
Well, if he actually looked at the data, then he would see that that the globe literally only exists within these refraction coefficients.
That's the thing. We can falsify refraction in so many different ways. Like, this isn't even the only way. And it breaks the whole like claim that they're trying to make. So then what's left?
Yeah, I know. What's left is you argue about something that it's not, like the observer to the peak. No one gives a fuck about. And try to make it into a curved visual space argument.
You say no one gives a fuck about it, but this is why everybody is like wondering what the fuck is wrong with y'all. Like, it's only like a few select guys in Ethicons that act very cult-minded, think that nobody else is comprehending their argument. And like everybody's on the outside looking in, like, look at these guys acting like they're making sense when they can't address the simplest point, that your flat earth trick prediction does not match reality. You say, it doesn't matter. No, it does matter. You don't want it to matter. I don't know why. It should matter to you. This is the only thing that should matter. And the whole thing is that it doesn't match your prediction for a flat earth with no refraction. It's like, it can't be refraction.
Does it match
There's
the
no
globe?
refraction happening now, guys.
Do you think it matches the globe?
Prove it. You got the data. You've got the data. Go crunch the numbers and show us and prove it.
Electric, do you think it matches the globe?
Stellarium is a globe model, and the observation made with the Theodolite matches the globe prediction.
So
That's
how do you
correct.
know that
Incorrect.
it didn't measure? If you didn't measure anything, right? All these variables in the that cause refraction, how the fuck do you know what's going on?
Yeah, it's not hard to comprehend what stellarium is. All angles to stars are
Not what I
subject
asked you.
to when you
Not what
move
I
away
asked
from the geographical position of a star, that is going to decline towards the horizon. And then you have the sidereal rotation, the azimuth angle is going to change as well. But every star declines
There
one
you go.
degree every 60 nautical miles. And you can measure this with two different observers. Just measure an angle to the same star from two different latitudes. And you could find out, you could do the math and find out that the angle to the star comports to 1 degree 60 nautical miles.
No one's arguing
Everybody
about
can do that everywhere they are on Earth.
Yeah,
That
no shit.
creates a celestial sphere. That is
Yes,
literally why
exactly.
people think Earth is a globe for thousands of years.
No shit.
Okay, so when you say that that's not the angle to the star, that there's a flat Earth prediction, right?
Is the celestial sphere the
Hold
Earth?
on. I think you're comprehending my point, so don't
No,
interrupt.
I'm not.
No, you're
It's
not
not that.
comprehending the point that all these angles to the celestial sphere actually comport with a globe. You don't understand.
Incorrect.
Okay, so you don't understand what stellarium is then.
Stellarium is based off the nautical almanac, dog. And you can use Gaia. You can use any type of other star viewing app, whatever you want. Doesn't
The
matter.
1 degree every 60 nautical miles is a non-linear relationship. It's not like you're actually approaching the base of, you're doing a trigonometric function, right? You're just measuring angles. You're not
Yeah,
getting the
exactly.
height of a star. Because if you were going to consider that you're actually getting under the GP and that was the height of the star, that puts the star at like 3,000 miles.
Yeah,
And
but
the
you
only
can.
point that I feel like that matters in this whole thing is that it doesn't match the flat Earth trig. It appears lower than your prediction, and you say that there's no refraction happening, while you say that there is refraction happening. It's double speak. So it's being
Nah,
raised
dude,
from its
you're
geometric
the only
position.
one that's making these arguments. You're arguing against a straw man. That's what you're doing right now.
You just pretend that you're smarter than everyone, but you actually don't make sense, dude. That's just all it is.
Nah.
That's so much
All this stuff about
projection right now.
eclipsing
That's
time,
exactly what you're doing. That's hilarious.
and the refraction before the mountain, like from the start to the mountain, like however much refraction would be happening due to the atmosphere. To
Okay, how much
astronomical
refraction is due?
refraction.
How much refraction is happening between you and the mountain peak? Or does
Yeah,
it
you can
change
measure.
dynamically every
You can
fucking second?
measure the density gradient near the
Okay,
surface
was
of
it
the Earth.
measured in these
It's a
observations?
stable condition. Typically, that turbulence that you have coming in does not displace the angle to the degree that you need it to,
Nah, dude, you sound like a glober,
because it
dude.
has
All the way-
already dropped over
It's
distance.
basically the same. There's a standard model of refraction that we can just apply. Come on, dude.
exactly what he's saying.
Flat
He's
Earth prediction with
reinforcing-
refraction. You
he's
agree
reinforcing
refraction
the globe.
exists.
You're
Therefore, the
reifying
angles to the,
refraction.
therefore the angle to the star from the house to the peak, the angle to the peak should have been like 2 degrees 45 minutes.
You
2
are
degrees 48 minutes.
reifying refraction. You are reifying the model of refraction. That's what you're
No,
doing.
we tested the atmosphere already, dude. We already
We?
know the density gradient in the atmosphere. It's a stable condition. We know
not
the
stable.
amount.
To walk
We
you
know
through
the
this.
amount that pressure decreases with altitude. You can measure it. It's
Electric. I
consistent.
tried to walk you through this. The NATO Sapphire is the exact like experiment you should look into, because it explains over long distances the refractive model falls apart. It's no longer reliable. 10% of the time you're going to be they were wrong to the refractive model. 2 to 4 times the allowed tolerance. Like, that's a big fucking deal, man. It's like you have a prediction that only works 90% of the time. and you're treating it right now.
90% of the people hear this
as it's
celestial
a
theodolite thing,
100%
and they think you
certain.
guys sound baloney. It sounds baloney because you're not
Oh,
addressing
you're
a
just
serious
talking.
Who's
issue.
doing
You're
an
talking. You don't
ad-hom.
want to hear a fucking thing, bro. Like anything that goes against what you have made up in
I've
your
already
mind,
heard it all, dude.
you
I
don't
went
want
to
to
your
hear it.
source. I heard it from your source.
Well, let
You're
me challenge
relaying what
you.
Alan says.
Let me challenge
That's
you
not
on
my
what
source, guy.
Hold on, Rager. Hold on.
Oh, your source for the celestial theodolite is not
Electric.
Alan and Dr. Mike.
Hold on.
That's great.
No, for refraction.
Yeah, we're talking about refraction here, and you're reifying refraction. You're basically saying it's a standard model of refraction. It's basically stable. The air is stable. Are you kidding me, dude? And not to mention, no one's arguing that you can't measure temperature and pressure and create a terrestrial refraction formula if you measure the density between you and the target. But here's the problem with that. We're talking about celestial refraction, all right? No temperature, no pressure variable accounted for. And so you're just applying it willy-nilly, you're reifying it with no justification. That's your problem, not my problem.
Is the path of light from the mountain bending down through the medium? Yes or no?
Then just going on to the questions.
Just answer it.
Yes, light bends towards a denser medium.
Cool.
But it
So
can
then
also
the
bend
mountain
up.
appears higher than its geometric position, right?
It could also bend up. No one measured
The
the amount
mountain
of
appears higher
refraction
than its
between you and the
geometric
mountain.
position.
We're going in circles. You're just asking the same question. I've already answered. No one measured the refraction between you and the mountain. Okay? No one actually measured it. It was just applied as a curve fit formula. We're just going to go over and over and over and over again. You want to keep reifying refraction? Fine, bro. I don't want to believe in fucking something that's completely dynamic if it is, a factor, okay? This is why surveyors use theodolites 100 meters from A to B to C, respectively, because of this. And you're going to say, oh, it's just, we have a standard model of refraction. Why? Oh, is it because it's a curve fit formula? Because we have to be on a ball, so we have to have some type of standardized model of refraction?
No, because we know what's causing refraction, dude. You measure the pressure gradient near the surface of water. It's due to water molecules. This is what's increasing the density in air. Duh. Okay, and then you have temperature. It literally heats up the water molecules and makes them move around so the air becomes less dense. We can test that this is what's changing the density in the atmosphere. This doesn't address the point that you keep cutting me off from finishing.
Does it change
dynamically? Is that if it is refracted up from its geometric position, then it's already being displaced after your curved visual space.
But see,
okay, so you have it being refracted up from its position that has dropped over distance due to curved visual space.
So it would even be
lower. It would be even lower than that. So it's so far from the flat Earth prediction already.
Dude, you're literally the justification for why the celestial theodolite experiment is even a thing. Because of the non-ending circular arguments of, is there refraction between us and the mountain? How much? Did anyone measure the density of the medium? It should be refracted up. Should be refracted down.
Honestly, dude, it's not a thing. It's literally so fringe, and the community is so small. The celestial theodolite has no impact on the tool stellarium.
Correct.
Stellarium is a tool to find your coordinate, dude. In a coordinate system, it's a coordinate grid. It's a three-dimensional spherical coordinate system, and it works all around the world. It works all around the world, and it doesn't match your prediction. Everybody can test to see if your prediction is correct or not, and it never is. You invoke curved visual space. You don't know why that's happening. It's already over. See, dude, this is where the conversation leads, is you pretending you're not comprehending anything.
You're just claiming things. You're just saying things.
I'm sorry, BS, please.
You're literally
I don't bring this. I never bring this smoke to you. You guys can have fun enjoying your thing. Keep having fun, dude. But a lot of people are looking at y'all like, how are you ignoring this?
Can you admit that you're reifying refraction? Can you admit that? You're just claiming it?
You're denying 14.7 psi near the surface of water. You're denying that we measured the density gradient. the typical stable conditions that you can measure. You're
Typical
denying.
stable conditions, he says. That's retarded.
That's the dumbest shit you could say, because I already explained to you how 10% of the time it's not typical. And it's so far away from typical.
Yeah,
But
that's
but
a
but
retarded
but
thing.
but
Times
global
outside of typical.
but global warming. But things are heating up and they're not stable.
But you keep granting yourself like this perfect fucking
Go get a
model.
barometric pressure gauge and go find out that the decrease in pressure with altitude, you can consistently measure this. Every day you go outside, go measure the pressure gauge.
Yeah,
And
you
then
can't.
get back to me and tell me how fucking turbulent it is.
They did it with
I think this is the
NATO.
biggest problem with the argument, man. Is the whole idea that, I mean, look, I know you guys are shitting on him, but I do agree that some of the shit he's saying is at least warrants interest. You know, like, I think it's dangerous to say in a public forum, the Earth is flat and there's no refraction.
No one's saying that, though. He keeps saying that there's no refraction.
I asked, you know, whether or not that is the real argument. When I asked the person who came up with this idea, he replied yes. So there's a communication problem happening at the very
Dude,
least.
yes, I went up on their Celestial Theodolite Mondays and I asked Alan and Shane, I said, why is the vertical angle displaced and lower than your flat Earth prediction? They both
asked Mike.
Curved visual space. Okay. And you also still have refraction. Still, the density atmosphere is raising that position. So it's actually like really far from your flat Earth prediction that you're championing and acting like, dude, we got to 2 degrees in 31 minutes. It's closer to the flat Earth prediction. No, it's not. Your flat Earth prediction is not 2 degrees in 31 minutes. It's like 2 degrees in 48 minutes. You're pretending there's no refraction. That's the whole problem. It sounds like some dishonest bullshit. And it's coming from Alan and Shane.
How can a star that you can't see any longer be refracting? Is it refracting, or can you not see it? And it's in the same optical corridor.
It got occluded by a mountain that's getting refracted.
Right, and you write down the time, and that it equals an angle, and that's where you get the angle from. Like, I don't understand what you don't understand.
How did you get the next angle, though? How did you get the next angle?
What do you mean?
Like the unrefracted true position angle is
There's four angles. There's four angles, Riggs, right? You have the observer to the star, that's 204, right? With a true geometric angle. Then you have 219 from the observer to the star as the apparent, the refracted angle. Then from the mountain peak to the star, you have 231 or 233 actually, as if you actually look at Stellarium for the occluded angle for the true geometric position. And then you have 246, right? For the apparent. Now here's the thing.
Fuck, I wish I understood this better, man. I'm so tired. I'm getting lost. I'm sorry.
There's four different angles, right? Two true geometric and true refracted or apparent positions, right? The one we care about is the refracted and the geometric position from the peak to the star, okay? When you see the refracted position, it's 246. Now, the thing is, we can't see the star anymore. So we don't care about the refracted position. We only care about the geometric position, right, of where it truly is in the sky. And when we say truly is, it's based off of 15 degrees per hour, based off of the first cusp of Aries, where they took zenith angles to these stars, right, which is basically at 90 degrees, which is the least amount of refraction that's actually going to affect the star, okay? And we're referencing that angle. Then we're taking that angle, right, and seeing what that angle, if that angle matches the height of the star, I mean the height of the mountain and the distance, okay? So the distance, there's only one true distance between the observer and the peak. Does it match the height of the mountain? It's the closest. It closely. Okay. That's what I'm saying. It closely matches.
is it? You know?
Let me pull up. I don't know if I have the updated
I mean,
spreadsheet.
is it like within
It's like
a wobble,
100.
or is it like
It's like 100,
Dude, you're
200
saying
meters
which prediction are you saying
versus
in that?
50.
hold on.
The flat Earth
I can
refraction prediction.
hold on.
Hold on.
We'll catch you up. I just want to get this straight real quick.
So the distance is closer by like a few thousand meters, and then the height is closer by 200 meters, 100 meters.
Yeah, it's still a lot though. Fuck.
But it's like that's just for one observation. When you look
Yeah.
at all the other ones, it's crazy.
What's the actual like mileage?
Dude, I have to look at the spreadsheet to give you the exact.
Dude,
It's all in meters.
100 meters, dude. That's fucking a lot, dude.
The point is, right? By doing this and basically being able to derive your distance and height of the mountain more closely shows that these celestial refraction coefficients are used indiscriminately only to do a curve fit formula, and that the globe only exists in refraction.
I agree. I think what it's indicating is it's more similar, but like when you're telling me that, like, oh, dude, I wish I knew the actual mileage because, like when you're saying something like hundreds of meters, I can't believe like this idea that we're like excusing that there's no light bending down between you and the observer, and that it's not like some predicted value.
The thing is, in some cases, the drop over distance, right, is equal to how much they are actually off by. In some instances.
Off by.
Yeah.
Off by from the mountain to the sky?
In terms of being able to derive the actual distance to the observer, right? So like if you have a certain distance, you have a certain height if you have the angle. You get what I mean?
Yeah.
So you have the angle.
Well, that's all.
Oh, I don't know. I don't know exactly. All I know is that it's showing that these expansion tables, right? When you see like all these coefficients for refraction that they're invoking, especially at the horizon, and how they're doing it, it's pretty, like, it's insane.
Yeah, I'm sure it's fucked.
It's to the nth degree, dude.
You said the amount of listen, dude. You said the amount of drop they're off by. What prediction?
Hold on one sec. My dad's calling me.
Prediction with no refraction. Prediction with no refraction. They're saying that they're off by this many degrees if there was no refraction on a flat Earth.
Dude.
There is refraction on a flat Earth. They say that there isn't.
Yeah, I know. I want this to mean so much more than I think we can claim it means. I'm like right there with like, oh, but it's not giving us a replacement. That's my fucking problem. Because and I know he's on the phone, but if anyone out there can please just verify I'm not losing my fucking mind. Fresh, maybe Leveless, like Rigger, just hear me out. If we're claiming the Earth is flat and we're using the current angles, okay, we run into a big problem because as soon as we start measuring, elevation angles, elevation angles in the south hemisphere, we're going to be looking the wrong cardinal direction. So clearly, we're missing something, right?
Missing a lot.
Well, okay, Beast, you're back. Look,
but it puts a hurting on the globe model. Like,
yeah. It definitely indicates that, like you found a knife in their backpack, and like you found somebody's body, but you don't know who the body is, and you don't really have any evidence that they did anything. But you found the fucking weapon, right? Like it's like, okay, there's some fuckery afoot, but what happened here? Look, Beast. Here's my biggest issue, and it's like the clearest, most glaring issue. And maybe you can tell me if I'm full of shit. But if you're defending a flat Earth prediction, which I'm fine with, I support that. If you're defending a flat Earth prediction, then your angle to the star would be pointing a particular cardinal direction, and in the south, you'd be literally facing the other way. So, I mean, without some other mechanism, how is that a thing? And so then this is what I think is dangerous when saying the true, like using words like true position, real star. Like there's a variety of these things that get said. And ultimately, as soon as you guys start listing shit in the South, hey, boom, bang, Glober says, hey, look, you're facing the wrong way. You're fucked. And now what? Now what? Now you've just hung yourself with a million evidences about flat Earth is true using this guy.
What's the facing the wrong way argument that you're making?
The stars go the other way.
How does that matter to this like celestial theodolite?
Because they're on the other
You
side
can do
of
it.
the
You
sky.
can do it as the stars come up, or you can do it as the stars go down. Doesn't matter. You can
Yeah,
time
but-
it with
okay,
the occlusion
okay.
of the star or with the appearance of the star.
But Rick, the argument needs to be consistent for every single star, not just the ones that ignore the glaring issue.
Well, I mean,
Okay,
43 out of 46 of them is a decent amount, and the 3 that are more closely associated with globe
Okay.
are basically equal ratios of drop over distance and celestial refraction invoked.
Okay. Well,
That's
do you
crazy.
guys know that meme of like the dog that's sitting on the table and he's like drinking coffee and the room is on fire and he says, "This is fine"?
Yeah, well,
Yeah, sure.
Here's my contention though, Riggs, because what we're doing, right? You're basically deriving distance, height, and angle, right? Like there's 3 parts of a triangle, and when you're doing that, when you're invoking that triangle, you're basically showing that Earth is locally flat everywhere.
Yeah, and facing the wrong way in the other hemisphere.
Yeah.
What is this
listen,
facing the wrong way? What's this facing the wrong way thing? I don't get it.
You guys don't get it?
I
You
don't
get
get
it?
it because if you're talking about the sky,
That's right.
right, the celestial
That's
sphere, how it works, I don't know, dude. I don't know how it works.
You're excusing the same problem that happens with the Gleasons. It's the 24-hour sun all over again. You're facing the wrong way. It's going the wrong way. So when you're establishing an angle and you're saying, hey, look, the angle's true. And I'd say, hey, look, the degree is accurate, but it's going the wrong direction. So it couldn't be the flat Earth sky unless you had a mechanism for why the star is 180 degrees on the wrong side.
I don't
See,
get that argument.
I differentiate between what the ground is, right? And it's like, dude, it's not curving away from us.
I can explain what Riggs is saying. Like Rick Sky, it's literally in your profile. You have A.E. Gleason's map right there. Okay, so when you're facing south, you're looking towards the south celestial pole, the counter rotation around Sigma Octantis. Right? All right, so like everywhere you look, which is south, is going to make you face that celestial position, right? So like when I'm facing south in South America, south in South Africa, and south in Australia, those are all different directions.
Can you just stop for a second? You guys say you're facing the wrong direction. What is the There's north, south, east, west. Which is the direction that is the right one, such that it's the like you can say that the south looks at the opposite direction.
Which way is south on A.E. Gleason's?
No, I'm looking
you can't have a flat Earth if the star is pointing 2 different places. Like, yeah, the angle is the same, but if it's pointing a completely different direction, then you can't build a map, and then you have a 24-hour problem in the south.
If south is just away from north, which is it's just a center point, right? If everything is just, if north is in a center and south is just away from that center, then when I'm in South America facing south and I'm in Australia facing south, these people are literally 180 from each other, and we're both looking south.
Are you occluding? Just stop for a second. Are you occluding, like with the celestial theodolite? Do you think that you ever look south or north with this?
To see Sigma Octantis and the Southern Cross? Yes, you can look south from South America and Australia and see the Southern Cross.
There's only 2 directions that you should be looking using. Like if we're talking about the celestial theodolite, the only 2 directions you should be looking are east or west, and you don't want to really be deviating more than 5 degrees from east or west. So when I say that you're looking west, you're basically looking west, or you're basically looking east. There is no south, east, southwest this sort of report. You're looking at a very narrow corridor from east to west.
That's true. You can either get emergences or occlusions. I mean, emergings or settings.
There is no, but like, why are they invoking looking north or south? We've got nothing to do with it. Like, you can't even do it looking north or south because of the way the rotations work.
I think they're making a different argument.
Because north is the direction of Polaris, which the geographical position of Polaris is geographic North Pole, dude. So if your map puts,
no one's including stars.
Your map puts the North Pole at the center, right? If the reason that your compass faces north is due to the pole, then all directions moving away from that pole is south. Okay, so when I'm in South America facing south, and I'm in Australia facing south, I'm looking in two completely opposite directions, and we're both seeing the same thing. We're both seeing counter rotation around Sigma Octantis, looking in opposite directions.
What's that got to do with the celestial theodolite once again?
It
Are we
doesn't.
shifting topics?
It's just
now?
It has to do with Stellarium.
Stellarium's fine. Like it's based on the GPs. So then when you start invoking or pressing the refraction button on Stellarium, and Stellarium has two functions, right? It can actually display what is effectively like a flat Earth or two planes, like the plane of the ground and the plane of the sky. It can be displayed like that, or it can be displayed as in like the pretense that those stars are underneath your feet, like the globe. Yeah, so you can turn that on or off. Both of them work. It's all based on the GPs of the stars. It's going as far as those positions are concerned, they don't measure them at the horizon. In fact, if you want to do any sort of navigation whatsoever with stars, I mean, I don't know what the tolerance is, but they're usually looking directly up at the sky. They're not really looking off into like far off distances on the horizon and looking at those stars.
Well, I reserve right that I could be like somewhat off on this argument, but I think I'm on to something at least. Like I'm very tired, so maybe I'm a little squeaky in the brain.
Yeah, right.
But this is like what makes sense to me, that if there is a counter rotation and you would essentially be looking into a large crescent of the end of the Earth, then that real position of the star would have to be somewhere like very distant and just like somewhere else entirely. So then you would have like completely different directions to the true position. Just my take anyway.
I don't know. Mixing up a lot of different things here. Some of it has something to do with celestial observations and what the celestial theodolite proposes. Some of it is just, well, what about this?
I think there's a missing element that is taking place, but without that more granular discussion, I think that the good, the GG is just not sufficient, because you're not going to bring anybody on board by like saying things like true position and no refraction, and then also not being on the mountain to see if it's even what they claim in the first place. So
I'd say, dude,
there's missing components to like be convincing to like real smart people, I guess.
And this is why, Riggs, in my opinion, this is why I'm just going to go do it myself. I think the best means of actually sort of participating within it is actually just to go do it. And I actually find anyone who's sort of arguing against it without having formally gone and done an observation, plug the figures in, understand how those two triangles are working together in order to reveal sort of to make an observation or a discernment between flat or curved. You can't just, what do they call that, armchair critique or something?
Yeah, no, I'm totally a bullshitter. I'm totally a bullshitter. But I do think that there's some really smart people, and when you say those things that I said to them, they're going to be dismissive of the claim. And like going back to like a Discord server and saying "GG, got him, boys" is not going to help us get anywhere with like, because I think it could potentially be a fucking banger argument.
I mean, it is.
And unfortunately,
you just don't like the rhetoric behind it.
I think it should be tested and proven more or something like that. I'm just afraid it's claiming more than it really understands yet.
I mean, it's basically being refined all the time.
Mm-hmm.
And it's because the foundation of
banger claim too. It would be so banger to
dude. The foundation of it is so solid. Like you said, it's like ooh, there's something here.
It's like here. You're fucking salivating. You're like, I want to bite into this, but it's not. It's not done cooking yet.
We're learning more shit about it every day because of like, all right, what I've learned is how celestial refraction is different from terrestrial refraction, and how it's completely based off of empirical observations and is not based off of any type of measurement whatsoever. It's just a curve fit formula for why stars appear the way they appear in reference to the Earth. Like, it's insane. It's like they're literally invoking curved visual space and just calling it celestial refraction, and then basically like using that to reify Earth curve. It's nuts. It's actually nuts. But then again, also in their paradigm is they literally claim it's locally flat everywhere.
Yeah.
So I mean, how do you win against that? And this is why it's such a banger of like a thing to figure out, because they're using something that they love, which is stellarium and the spherical coordinate system and the celestial sphere, and how they basically engineered the globe from it in the first place, and basically using it against them. And they hate it. That's the real truth behind it. basically showing that their model is just that, and it's just completely reified based off of empirical observations, which are basically just trig, just angles to stars, then reifying their position over a time coordinate, essentially. Right? Like time equals angle, but it's basically just based off of 15 degrees per hour. Right? Like you can go to a GP of a star, and that shit will be there all the time. Like, that will always be there at that certain time. If you come back a year from now, it will be there. Like, the most accurate reference that we have as people are the stars, right? We use it as a clock for like a month, a day, a year. We use it to predict certain, astrological events like the lunar cycle, the eclipse cycle. Like, dude, of course you would use the stars to basically reify your model.
Yeah, it's the most reliable thing we have.
Right. And what they've done is basically fine-tune the celestial sphere in such a way to where they comport it with globe measurements, but it's not really a measurement, because when you actually look at what they actually measured, right, they only measured like 2 kilometers of an arc meridian or whatever, and basically calculated the rest. So, I don't know. I'm fine with not claiming like Earth is flat. How flat? Well, it has mountains and valleys. Okay. Well, then now you're granting that, right? So if I get that granted, then when I say, well, it's not a ball, yeah, it's not a sphere, it's an oblate spheroid, right? Now I have to grant that, because it's like, oh, it's not really a sphere, oh, it's not really flat. This is what Galatrax was saying, and it's totally true, right? Like, it's not really flat if it has plains, valleys, and mountains type shit. Technically, that's true. And they can say the same thing about the spheroid. Well, it's not really a sphere. It's an oblate spheroid. I don't know, dude. It's fucking crazy. The dichotomy just never ends.
Dude, I'm so jealous.
What?
Oh, I wish weed was recreational in Texas.
Yeah, I'm high as fuck.
I'm so fucking jealous. Unreal. Were you around when I was eating cookies like crazy? Like 2 years ago?
Nah.
Oh,
Maybe.
bro.
I have seen you high as shit before.
I wouldn't go to bed unless I had like I wouldn't go to bed unless I had like, I don't know, 120 grams of edible.
It's a lot.
That was a daily. Well, you just, you get used to it. Your liver adjusts, becomes like the normal amount. 60 to 100 or 120. 120 would be like a big dose for me. But like 60 at least. 60 would just like, it would start me off.
A lot, dude.
Is it? Is it a lot?